In this problem, we want to write the equation of a polynomial that has zeros at -4 and 2 plus I. Well, as we learned in the last video, we can't have just a single imaginary solution. Imaginary or complex zeros always have to come with their conjugate. So if 2 plus I is a solution, then 2 minus I has to be a solution as well. Rational solutions, or integers like -4, those are okay to come solo, so I don't need the opposite of that. So it turns out that this problem has 3 total zeros. So -4, 2 plus I, and then 2 minus I are going to be my 3 zeros. So I know I have a third degree polynomial. That's what this least degree is talking about. So the least degree that this could be is a third degree polynomial. So here's what we're going to do to start this problem, and it is going to be tedious, so you have your advanced warning. If I have a zero of -4, that means my factor, if I think backwards, would have to be x plus 4. I'm going to do something similar to get my factors to get these two solutions. Make 2 parentheses, and you're going to have to make these a little bit bigger. And they both start with x. It's a common mistake for people to leave out that x in the first spot. And just like we took the opposite sign here, I'm going to take the opposite sign of both of these terms to get these parentheses filled out. So to get 2 plus I as a solution, I must have x minus 2 minus I, because I take the opposite of both signs when I plug them into the factor. And then to get 2 minus I, be careful, I'm going to take the opposites, but that still leaves me with -2, but then plus I. Since that 2 is positive in both parts of the problem, or in both zeros, the 2 is positive. In both factors, that 2 is going to be negative. It's only the I that has changed signs. So this is what I need to multiply together, and this is where the problem becomes a little bit tedious. When you do this part of the problem, you have to, I guess you don't have to, but you'd be crazy not to, multiply these 2 conjugate pieces together first. Because even though it's going to be kind of nasty, what's going to happen is all those really nasty parts are going to cancel out, and they're going to go away as we start doing our multiplication. So as you guys know, I prefer the box method for multiplying polynomials, or multiplying I guess trinomials in this case. So I'm going to make a 3 by 3 box, and outside of it I'm going to write what I'm multiplying together. So x and -2 and -I, and then x and -2 and positive I. And so as I start filling out this box, I just need to multiply rows and columns together. So x times x is x squared, -2 times x is -2x, nothing weird so far. But then I times x, here's our first weird piece, I get -ix, or xi, it doesn't matter. Which is weird and kind of like Roman numerals, but it's okay, it's going to go away soon enough. If I continue this, then I get -2x, +4, and then +2i. So there's another weird piece, but again, don't worry, that weird piece will go away. And finally, as my bottom row, I times x is ix, or xi, -2i, and then finally I squared. Well, let's take a look at what happens now when I start adding up like terms. I've got a -xi and a +xi, so those have canceled out. There's one weird thing gone. +2i and -2i also cancel out. And then finally, -I squared. Remember, since I squared is equal to -1, -I squared must be the same thing as -1, or just +1. So this last piece just works out to be a +1. So if I take all this stuff and pull it out and add up like terms, I get the quadratic x squared minus 4x and +5 if I add up my like terms. This is a good time to pause and just check that you haven't made any mistakes so far. What I'd recommend you do is go ahead and use the quadratic formula on this, or if you have the quad program on your calculator, just check that and make sure that that does get you the zeros of 2 plus or minus I, the zeros we started with. So now's a great time to pause. I know this is a long problem. Pause and just check that you haven't made any mistakes so far, because the second part of the problem begins right now. So there was one more piece I had to multiply, and that was this x plus 4 piece. So let's take what we have in blue down here and multiply now by x plus 4. This part isn't nearly as bad. So again, I like to use the box method for multiplication. You're welcome to multiply however you'd like to. So in this case, I'm going to draw a 2 by 3 box and write what I'm multiplying on the outside. So an x and a 4, and then along the top we had x squared minus 4x, and then +5. Okay, so once again, let's go ahead and just multiply rows and columns together to get the box filled out to get our final polynomial. So x to the third, remember when you multiply, you change the exponent, you add the powers together. -4x squared, and then 5x. The bottom row will be 4x squared, -16x, and 20. The other thing I like about the box method is your like terms are organized and they should be like right diagonal from each other. So finally then, let's go ahead and pull everything out and add it all together. So I end up with x to the third. My x squared terms actually cross out. That was a coincidence. Then I end up with negative 11x and finally plus 20. To make this all function-like and polynomial-like, let's go ahead and throw that f of x equals in front. And there, after all this time, is the polynomial that will have those three zeros we started with. -4, 2 plus I, and 2 minus I.